6.6 Financial Application of Recurrence Relations, Geometric. This is the second in two videos, the first being arithmetic and this one here now, geometric. What is reducing balance and compound interest? Our success criteria, I can define depreciation, and in this case, let's not use an eraser, reducing balance, depreciation, and compound interest. I can find reducing balance depreciation and calculate future values using recurrence relation. As you can see, I just copied and pasted from the previous video and forgot to edit. Reducing balance depreciation, recurrence relations. Reducing balance depreciation calculates the future value of an asset by reducing it every year by a fixed percentage of its value in the preceding year. With flat rate depreciation, the percentage each year is of its purchase price, so it's the same dollar amount every year. So for example, that $10,000 car is depreciating by $1,000 every year. End of the first year it's worth $9, end of the second year it's worth $8, end of the third year it's worth $7, and so on and so forth. With reducing balance depreciation, the dollar amount of the depreciation changes every year. Now the percentage, for example, if your car depreciates at 20% per year, that 20% stays the same, but the value that it depreciates by, or the dollar amount that it depreciates by, will decrease. We'll go into that in an example on the next slide. The future value can be written as a recurrence relation. The recurrence relation for reducing balance depreciation after n years can be modelled by a geometric sequence recurrence relation when the common ratio is between 0 and 1. So we're talking a decimal figure. In 6.2 was geometric. We had a look at our sequences, which were T of 1 equal to our A value, T of n plus 1 is equal to A r to the n minus 1, or T of n plus 1 is equal to T of n times r. In 6.6, so I'm just realistically with geometric, finance and geometric with reducing balance depreciation, and later with compound interest, it's just reiterating what you learned in 6.2. So 6.6, instead of using T's, we're using V because we're talking finance, and we're starting with our initial term being 0 instead of being 1. It's still equal to A, the purchase price of the asset. Still, V of n plus 1 is equal to R V of n, which is pretty much just the same as what we had in 6.2. So, V of n is the future value of the asset after n years. Same as arithmetic, we're not changing that. V of n means how much is it worth? A is the purchase price. Again, we haven't changed that from arithmetic. And R is the ratio where the value of the asset each year compared... R is the ratio of the value of the asset each year compared to the previous year. So, worked example 13. For anyone following in the textbook, it is page 288. A business purchased a photocopier for $10,000. It is depreciated using reducing balance depreciation at a rate of 18% per annum. Now, if you remember from 6.2, if you want to find a recurrence relation, all you need is A and R. That's it. From that, you can plug those two values in and find any term within the sequence. This really isn't too dissimilar. A business purchased a photocopier for $10,000. Our purchase price, my A. It is depreciated using reducing balance depreciation at a rate of 18% per annum. Now, our A question states, what is the value of the photocopier in any 1 year as a percentage of its value in the previous year? If you had $100 and you were losing your money at a rate of 18%, you only have $82 left after that first initial sort of loss. So we're working on this pretext. We're starting with our 100% amount, which in this case is $10,000. Then we're going to subtract 18% per year. We're going to end up with 82% of the value. So what is the value of the photocopier in any one year as a percentage of its value in the previous year? It's only worth 82%. And part B, write down a recurrence relation that gives the value of the photocopier after n years. So all I'm going to do is I'm going to convert my 82% into a decimal. And that's my R value. I've got my A value, and I can plug everything into the initial recurrence relation that we had. V of n plus 1 equals R V of n. So substituting in V of O equals 10,000, my initial amount. V of n plus 1 equals 0.82 V of n. All right, on to part C. Use recursive computation on your CAS calculator to find correct to the nearest dollar the future value of the photocopier after 4 years. So if you're using CAS, you can watch the geometric video. But in summary, you put in your 10,000, you press enter. You put times 0.82, enter. It should give you 8,200. Then you press enter again, and it'll then give you about 6,700-ish. Press enter again, about 5,500, and so forth. All you need to do, as I said, put in your initial number, press enter, put in the operation, so the times, then the decimal figure that you've got, 0.82 in this case, hit enter. Each time you want the next year's value, you just keep pressing enter. If you don't have a CAS handy or want to do this manually, we do it this way. We've got our V of O equals 10,000. V of 1 is equal to, let me just get rid of that and put R V of n, which is equal to 0.82 times 10,000. Oh, it's 100. That's too many zeros. Equals $8,200. Now, when I'm calculating V2, I then have to use my 8,200 because that's now my preceding value. So I do my 0.82 times 8,200 gives me 6,724. Go back to blue. I'm not liking red. V of 3 equals 6,724 by 0.82. Yes, I've mucked them around. I've done the R times V, then the V times R. It's whatever works for you. And that gives me $5,513.68. And then my V4 is 5513.68 by 0.82, giving me 4521.2176. So I've just used the calculator and put all these values into the calculator. Let's write that neater. There we go. But it asks me round the answer to the nearest dollar. So, oops. After 4 years, photocopier will be valued at 4,521. Now remember, if that was above 50 cents, you'd be rounding it up to 22, but it's not, so we'll keep it as it is. Now, use the graph to find the photocopier's approximate value after 8 years. Now, that's after 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, 7 years, 8 years. It is approximately $2,000. Now, if you wanted to keep going through your CAS, you're welcome to give me an exact value, but it's up to you. It's worth approximately $2,000 after 8 years. All right, moving on to compound interest recurrence relations. Most investments are compound interest investments, where interest is calculated on the original amount plus any interest added until that time. For example, you invest $1,000. At the end of the first year, you've suddenly gotten 10%. It's worth $1,100. For the second year, they calculate your interest based on your $1,100, not your initial $1,000. So the longer you can keep your money in, the more it grows. Based on this, compound interest, if the interest rate is much the same as simple, compound interest overall will give you a better figure. So the recurrence relation for compound interest investments after n years can be modelled by a geometric sequence recurrence relation where the common ratio is greater than 1. V of O equals A, V of n plus 1 equals R, V of n. All right, exactly the same as what we've got for geometric in chapter 6.2 and as well as the reducing balance depreciation. But the only difference is our common ratio is now greater than 1. So V of n is the amount in the account at the end of the nth year. A is the original investment, R is the ratio compared to the previous year. Best way to figure out what to do is worked example. If you're following the textbook, we're looking at page 291. All right, Alan inherits $35,000 and decides to invest it in an account where he earns 6% per annum compounded annually. All right, 35 is my A value. I've got a 6%. Write down a recurrence relation that can be used to describe the value of his investment at the end of each year. Now, the first step you need to figure out is what your R value would be. So previously we had 100% minus the 18% for reducing balance. But when we come to compound interest, because we want to increase our value, that was for reducing the value. Now we're increasing our value, we're adding our 6%. Gives you 106%. But we don't want the common ratio as a percentage, so we convert that to a decimal figure. And there's our value greater than 1.06. Then we put these two, our A and our R values, into our formula. V of O equals A, V of n plus 1 equals R V n, and we come up with V of O equals 35,000, V of n plus 1 equals 1.06 Vn. So every year you're going to get 6% on top of the previous year's accumulation. So use recursive computation on your CAS calculator to find the value of his investment after 4 years to the nearest cent. Now, using your CAS calculator, you would just put in your 35,000, press enter, then multiplied by 1.06, then press enter again. And you keep pressing enter each time until you come up with the figure that you're after. So we'll do this the old-fashioned way, pen to paper. V of O equals 35,000. Now I don't have any answers here already, so excuse me for taking my time on this. V of 1 is equal to 1.06 by 35,000 equals 1.35. Let's see if it works on this. 35,000 equals times 1.06 equals 37,100. 37,100. V of 2 equals 1.06 by 37,100. Oops, wrong one. Haha, it does work. 39,326. V of 3 equals 1.06 by 39,326. 41,685. 85 point, what do we come up with? 56. And V of 4 equals 1.06 by 41 point, 41, oh my gosh, I don't even know what I'm doing. 685.8 0.56 equals 44,18669. So because that's over 50, we, after 4 years, 44,187 is what the value would be rounded. So most of the time the banks would probably round it, or you'd like to think the banks rounded it. We'll see. All right, so we've done A and B. Now what I'm going to do is I'm going to add another page. And I'm going to quickly do the simple V compound. So, previous slide, 44,187 after 4 years. So we started off with 35,000, ended up with 44,187 at 6% compounded. Now, 35,000 times 6% gives you times 6% gives you 2,100. 2,100. So at the end of the first year, add 2,100. We get 37,100. Second year, we add another 2,100. 39,200. Third year, 41,300, and fourth year 43,400. So as you can see, between this value and this value, there's about $700 difference in favour of compound interest. So if you are investing your own money, my recommendation is compound interest.